Hi, I'm Pagda12 and today we play with particles and I will show you how to build a smoother limit as we already built in a previous tutorial. So here we have a network. It's very similar with the one covered in a last tutorial. And we have a feedback, and always we add a little vector, and we limit everything here on x and y as we have a ratio, okay? And the problem, we have two problems here, right? First one is, you see the circles disappear right when the center hits the edges, okay? So I would like to have a much smoother limit, and the circle would be nice to completely go out of the screen and enter again. And the second one, it's how about the zigzag? Why this doesn't work? So now, most of the spheres, as you see here in the geometry, will go on the edges and stay there, and yeah. And this is because we need to change the direction of the vector. Okay, when a particle hits an edge, we need to multiply with -1 either on x or y axis, depends on the edges. Okay, so let me show you, because we don't build this from scratch. I will walk you through those components, zigzag and a loop. Okay, and let's see, for the loop we need to add in a classic manner. You need to add or subtract 1. Okay, when you are in hit this edge to go here, okay, you either subtract 1 or add 1. So for the case we have a square, and it's 0, 1 for both of the axes, but here we have a ratio, and so on x we are good, on 0, 1, and on y 0 to ratio. Let's use this here. So let me bypass this limit. We don't need this. Okay, and okay, and now we connect this, and let me reset. You see now every circle gets completely out of the screen and enter again nicely and very smooth. And this is done in a manner I like to call the folding or parallel computing. You know, imagine on this band we have the extremes 0 and 1, and we need to act when some particles hit those extremes. And it's a case where some particles are hitting one, left or right side, and some others will hit the 0 side, the opposite side. Okay, now I would like for I don't know for what reason I thought it's for optimization, but I believe it's much better for the way of thinking some simple mathematics. And imagine we want to modify this length. Okay, this imagine this is a wire of numbers. Okay, so we stretch it 2 times and then we fold it. Okay, and when we fold it, because I stretch it 2 times, as right after folding I have the same size. And when I fold it, I have the 0 cases and 1 cases in the same spot. Okay, in my case it's the one side of things, I would like to say. Okay, let's go inside and actually see this. Okay, now don't be scared of this network. It's quite easy. Okay, so I use a feedback to take the position. Position is here. Okay, it's right here. It's the texture that I'm using for instancing the sphere. Okay, so I take that with feedback, and I want to work on X and Y separate. Okay, so here we want to mark the points that are getting out of the edges, right? And for a smoother transition, we need to wait till the points go outside 1 plus the radius, okay? And it will need to jump back at 0 minus radius, or this travel, it's actually equal with 1 plus 2 radiuses, okay? And you see for X and for Y, red and green, I use two layers, okay? So first I want to see how I use round matte here to mark with white points that are about or possibly get closer to 1, right? The right half. On the camera it's switched maybe, but the points closer to 1. And I do this with round, and then I want to remap this into 1 or minus 1, because remember we have to solve an addition, minus 1 plus 2 radius or plus 1 plus 2 radius. So yeah, let's see. So here we range that, okay, and we have a matte here, and we take 2 radiuses, right? Right here we multiply two radiuses here, okay, and we have 1 plus 2 radiuses. It's exactly the travel of the particles, okay, on a x-axis extremes, right? So we got it here, right? And here we multiply this with the texture that we have minus 1 and 1, and yeah, we good. But imagine in this texture all the points in a half right or half left are marked like this, and there are only couple of them really hitting the edges. And let's find them, okay? In the second layer right here, I multiply with 2, offset to minus 1, and then by this positive here I fold it, and now I'm only take care on the one side, okay? And I do the subtraction. So I subtract 2 radiuses, okay? And imagine I subtract 2 radiuses as I'm switched, I'm stretched, okay? And here I'm checking with minus 1 and ceiling. I'm checking the points that are go outside 1, okay? Are in our case, between those marks, those points are the ones that are on the other edge, right? But we fold them, okay? So I use this limit, as I always use a limit right after I really need the texture 0, 1, because this is the texture that I want here, okay? So with 0, I will mark the points that are, okay, are in the half right, are one of the halves, but not hitting the edges. So we only the white pixels are hitting the edges, so I need to make the transport, the addition 1 plus 2 radiuses only for them. Okay, so now I have that, and I reorder in something that takes also the y-axis. It's all similar. Okay, so let's see here, as we take the position for the y. Okay, and because of the ratio, I will multiply with the ratio, and now we good, because we want to separate left and right halves, and I do this to have a precise calculation. Okay, so here we multiply by 2, so 2 times, and we subtract the ratio. Okay, and then we fold here with positive, and then right after subtraction, when we check the points that are going higher than ratio, not 1 as the case for x-axis, right? So everything it's similar. Here I take the 2 radiuses and I pre-add the ratio. Okay, and yeah, this is how smooth loop works. And let's have a look. I will put it aside here on zigzag. Okay, so you see now they go away. Zigzag, it's something else. Zigzag is multiplying with -1 the force that it's for the particles. Okay, when the particles hit this edge, that I need to switch the direction on x-axis for this particular vertical edges. Okay, and yeah, let's see. Okay, and yeah, let's use this. Now let's have a look here. You see all the particles now are bouncing nicely, but some of them are stuck on the edge, and this is because on a starting position that sphere was outside or already crossed the border. Okay, and we can solve that here in the count, where we take some noise here, and in the count we limit that according with the ratio, and then we want to form a nice texture with black where we don't have values. Okay, so here we can use a blur just to get all the values in the middle a little bit, to reduce chances one of the sphere will cross the border. So yeah, let's use 2 here, and we press 1, and now all the circles are in the middle, and they are bouncing forever now. And yeah, let's see how is that. Okay, so again, we need either 1 or -1. 1 for the particles that doesn't need to change anything, they are inside, and -1 for some of them who hits the edges. Okay, but only for the x or for the y, depends. And let's go inside here. And again, we do the same trick with folding to treat the edges the same. And again, we multiply with the two of the 2 times radius. We split the coordinates on x and y, yeah, red and green, and multiply by 2 -1 positive. Same old story, and then we add, right? Because when we zigzag, the points travel not all the distance between 0 1. It's travel between 0 plus radius and 1 minus radius. Okay, there the bounce happened, and I will add 2 radiuses here. Okay, and then I check when it's bigger than 1. So the position on X plus 2 radiuses, when it's bigger than 1, is the case for the zigzag. Okay, is the moment where I need -1 either for X coordinates or for Y coordinates. Okay, so as we started with 2 parallel lines, X and Y, yeah, it's much simple to see. So I use the checking, okay, with ceiling, -1 and ceiling, as you can see, and the limit. And here, it's a little tool that I built, as it solves Modulo 2, and I was thinking, okay, I need to know, and if a particle hits a left, then it needs -1, and then hits the other side, I don't need that minus. Okay, so I have to switch, multiply again, and then sometimes I need minus, sometimes I don't. And yeah, I was thinking to build a Modulo 2 and a Modulo 2, and right after that I will see. But I was nicely surprised to have right out of Modulo 2 component everything needed for the algorithm. Okay, so this is a little brain that keeps track of if is every second hit of the edges, it will be treated with minus. Every all the others are treated with plus. Okay, so let's go inside. Yeah, I use a feedback, and what's coming, I treat what's coming as 1, 2, what the numbers, the count, and I do an add and keep the results in a feedback, and so I know how many times a particle already hit the edges. Okay, and then I do the modulo by divided with 2, and then multiply with 2, and make the difference to see to check the rest of the, and I get this texture out, and so I have 0 for the pixel that needs to be treated as in a zigzag. Okay, so where I need that minus for my force. So as you see, I rearrange 0, 1. Okay, right after Modulo 2, I rearrange in between 1 and -1. Okay, and this analysis is only to check if I ever need limit right after this, but no, you can't get anything bigger than 1 or 0 from this Modulo 2. So yeah, I needed to check that. So this is why I have no limit here. And then I reorder. So yeah, it's everything I need. Okay, so yeah, this is the tutorial that I wanted to, no, not actually the tutorial, but yeah, the walkthrough. I wanted to show you these little tools, because sometimes, maybe when you feedback, maybe when you do some, I don't know, imagine you have some spheres, 3D spheres, and would be, just a second to, okay. So it would be not so nice when quite a big sphere would just disappear when the center hits the edges. So this is, and also something treating whatever force you give them. Okay, the algorithm, it will work. So I hope you like this. Thank you so much for watching, and thank you, Messi, for your support, and see you in the next one. Bye.